Okay. Then the next thing that we're going to look at is how to exactly define this uh, heat energy required for change of state. So we define it, we call it latent heat, and depending on the change of state it is associated with, it would be latent heat of melting, it would be latent heat of vaporization or boiling, it would be latent heat of condensation. No, just the latent heat of melting and latent heat of condensation would be the same. If it gains that much energy, it will vaporize. If it loses that much energy, it would condense. So latent heat of melting and latent heat of condensation are same. Latent heat of latent heat of melting and latent heat of solidification are same. Latent heat of vaporization and latent heat of condensation, they are the same. Okay, so the two reverse processes, they would have the same energy. One gives it out, the other absorbs it. So now how we are going to define this latent heat, that's the next question. When you're defining latent heat, so it's basically the energy required to change the state of that substance. But there we just don't define latent heat, we like straight away define specific latent heat. Okay, specific latent heat, that means just like how in specific heat capacity we were talking about 1 kilogram of a substance, here also we're going to talk about 1 kilogram of a substance. So when you define specific latent heat, you define it such as it is the energy that is required, or the heat energy that is required to change the state of 1 kilogram of a substance. Okay, so latent heat means the energy that is required to change the state of a substance. Specific latent heat means the energy that is required to change the state of 1 kilogram of a substance. So when you bring 1 kilogram, then it becomes specific. So the unit of latent heat, specific latent heat, would be joules per kilogram, right? The energy required per kilogram. And yeah, there can be different latent heats. Latent heat of melting. Melting is also called as fusion. So when we say latent heat, we generally say it as latent heat of fusion. Similarly, boiling is called as vaporization, so it is called as latent heat of vaporization. So the energy that you give is equal to the mass into the latent heat. If for 1 kilogram you need L joules of energy, then if you have M kilogram, then you need M into L joules of energy to change the state, right? Just a couple of day-to-day application, you can call it, or jokes, you can call it. Just want to show you. So the good thing about water, beside it is needed for our survival, is that it has a very large latent heat, both in the case of melting and in the case of vaporization. So the thing is, to melt the ice, now it would need a lot of heat, so the fish has to lose a lot of heat before the temperature of the ice can change. And if you already know that heat flows from high temperature to low temperature, so as long if the ice is kept at if the change in temperature of the ice is slowed down, then the change in temperature of the fish will also slow down. Similarly, again, you can read this. And this one. So you have to be very careful about latent heat, hidden heat, when you're cooking. Not only that, the reason why you feel refreshed, like you feel that sense of cooling when a breeze passes by you after you have done a workout or like a very tiring exercise after a lot of sweating, is the sweat is becoming vapor, and during that process it is absorbing the latent heat of vaporization, that much energy from your body. So your body temperature, heat energy is lost, so your body temperature goes down. Okay, you might be wondering that isn't it the same thing that is happening in evaporation? Yes, in evaporation also what is happening, the molecule is becoming vapor. There it is a individual phenomenon, one or two molecules become, one or two in the sense a comparatively few molecules. Here the entire body of the liquid becomes vapor.